Well, hi, good morning, and thank you so much for joining me in my shop here. It's the 4th day of December, 2023, and I have another little tiny radio here to work on. This is a very small radio, very small. Small tube radio in a metal cabinet. Silvertone. Oh, there's a message. Loud hum. No stations. Well, that's what I'm here for. To see about fixing that. See if I can get this off now without pulling paint. I do not recommend people stick stuff onto radios like this. There we go. Okay. There's another remnants of another sticker here. Paint looks a little faded on the top there. Oh, a little bit of information here. I got a tube layout, patent notice. When ordering chassis parts or writing us about this radio, always quote the chassis number. And it shows where the chassis number can be found. Okay, we got to take this little guy out of his cabinet and have a look at him. Look at the antenna on the back of this. So this is just a wrapped up excess wire here. You'd unwrap and throw out as a wire antenna. Is it going to work wrapped up like this at all? Up against a metal back? Well, I guess we're going to find out, aren't we? Somehow I don't think that can work. Not very well, anyway. A metal can radio, so it's got it bound to be a 5-tube or maybe even a 4-tube radio. Bound to have chassis voltage problems. How do they deal with this metal can on the outside of it? There we go. Okay, so the speaker's got a big hole in it there. Four tubes. So it probably has a solid state rectifier in here somewhere. Pretty clean under the inside. Oh. Okay. This is just like the other radio that I just did. Little tiny radio, just a few parts. Where's that rectifier? Oh, I just put my finger through the speaker. Going the wrong way, Jim. I see this very special wire right here. This is actually a resistor right here. Well, maybe the rectifier is one of those tubes. I don't see anything. Looks to be in good shape. Any more information? Oh, there is some. There's a circuit diagram inside there, but not in the best shape. And there's probably a parts list here. Yeah, it says parts list. Okay, I think I'm going to hunt down the. Well, wait a minute. There's a tube layout diagram right there. Let's see what these are. Supposed to be 12 SA7, 35 Z5, 50L I can't read that one. It's going to say 50L6, but I'm not sure about that. 12. Another one where it's got too many letters. 12 letter number. Yeah, okay, I don't know about that diagram. I'm going to try to hunt down a schematic here. You can see right there it says 12SQ7. Is there like a big resistor in here? Like a big high, where would they hide a big high wattage resistor in a radio like this? Probably want to mount it on the metal. I don't see it. How are they doing this? How are you taking the 150? I'm sorry, 120 volts that's coming into it and sharing it across how many tubes? 4 tubes? Schematic. Let's look at the schematic. Surprisingly, this has come from Radio Museum. Surprisingly enough, the fellow who uploaded this diagram did it just 6 weeks ago. So right in time for me to come along. So let's look for a few key things. I'll start with looking at how the power supply is kind of handled here. So we see a dark line drawn across. This is going to be the B- bus line. And off that bus we see this and that. Do we see any more of these ground symbols anywhere? There's one here on the speaker. The speaker coil, I'm not sure about the frame of the speaker, but oddly enough they've done this. Why would they do that? So this is connected to the connected to the chassis through a large resistor here, 300K, and a medium capacitor. Okay, so that answers how the chassis is handled. It's isolated but drained by these. Okay, let's take a look more at the power supply here. Well, they've drawn these tubes in an unusual way. They're showing physically the location of the terminals, the ones that are being used anyway. Okay, we see off this. Let me zoom in a bit. So what I'm trying to pick off here is okay, so here's a heater. Good. Here's a heater. There's a 47 ohm resistor here, which is going to be dropping the excess voltage, because I think if you add the tube voltages, so you got 12, 12, and 50, that's 75, and you got 35, so that's 80 and 30, that's 110, but you're going to get 117 volts. So what do you do with the excess voltage? Not very much, really, but they're dropping it on with this 47 ohm resistor. We'll have to find that. On the cathode, there's a 15 ohm cathode resistor, cathode bias. Oh, what am I talking about? What am I saying? Why have they done this? They've done this to generate a negative voltage. Be quiet now, Jim. I don't think you know what you're talking about here. So that's the main filter capacitor. Is that the only one, or they hide another? There's another one here. And another one here. Three of them. 3 large filters. And that's in the form, I'm sure, of just one capacitor. Yeah. So there's a capacitor in here with 3 positive leads and 1 negative lead. So that's got to be this one. Okay. Why am I'm forgetting now. Why I'm looking at this just to get the general layout and the safety issues clear. The antenna. Hank. Okay, don't know what a Hank is. Iron core transformer here. Okay, nothing terribly unusual about this radio. It's quite straightforward. It's only one IF. This is how they've got it down to 4 tubes. Am I seeing this right? It looks like it. Only one IF. So the signal comes in here, it gets converted. If any of the converted signals are matching 455, they go through. And they're right into this diode. This is a cheap little radio. That's what you would call this one. It doesn't even have a loop antenna. So I think this guy's only hope is to pick up very strong, very local stations. I think that's the objective. Okay. Any reason why we wouldn't try it out now? We'll just look for this resistor right around this tube, the 47 ohm resistor. Just see if it's burned at all. Shouldn't be. I'm gonna put my fingers through the speaker again. Almost. Okay, so the rectifier tube looks to be this one here. Follow the power cord in, and sure enough, power cord connects right to this tube. This might be the 47 ohm resistor right here, this piece of wire, because I think you can dissipate a fair bit of heat on this wire. I'm chasing the wires around, that's why I'm moving the radio so much. We can put an ohmmeter on that and see what it says. Provided I can find my ohmmeter here. Forty-seven. Okay. That's good. Let's turn this guy on, see what happens. And my goal with this radio, like the last radio, is to do as little as possible. Excuse me, to it. So it's on this light, one light, nothing happening. Maximum voltage today is 117. Here we go. Okay, all's normal. The tube's lighting up. Of course, if one tube lights up, they all have to be lighting up. Hummer, she's a Hummer. She's a bad Hummer. Okay, so one thing we have to do, if I turn this radio right upside down, it's sitting right on this. And this, and the tube. I did it once already. Do it again. Not very heavy. Okay, we're going to have to go after that 3-part capacitor. I'll start working on that. So what I'm going to do here is I'm going to use 3 47 microfarad capacitors. That's bigger than what the what is in here. What's in here is a 40-20-20, and I'm going to do 50-50-50. And that shouldn't have any consequences, I would think. If the original radio designers could have seen their way to it, they would have put in bigger filter capacitors. But you know, they're operating under cost pressure all the time, so they're doing the lowest cost approach to things. So what I've done is I bound together the negatives of the 3 capacitors. Now the one that's in there, so, well, these wires are really flexible. Oh, maybe not this one. As usual, the green one is no good. And there's another, it's probably blue. Oh, it's stiff also. This pink one's okay. Okay, so we'll preserve the pink one as much as possible. The others we're going to get rid of. I'm going to leave some pieces on here so I can to mark where these wires go. Yeah, the insulation was just shattering there. Now what about the black one? Feels flexible, so we're going to leave a lot in there so I can use it. We want to take this big capacitor out of here. It's bumping into this. Oh my gosh, hey, what are you doing? Look over here a little bit. It's bumping into this terminal. Oh my god, I can shove it right out here. No, can't come out there. I just put my finger through the speaker again, didn't I? Oh my gosh, how stupid. How many holes am I going to put in it? Yeah, you know what? I think I put my finger through the same hole. Okay. Now, I'm going to put in the... where'd they go? Capacitor. So we have the black wire. Here it is. It's quite flexible. We have the red wire. Which can go almost anywhere. So really, it's the name of the game here is. I wish the black one's a little longer. It's get the 2 connected to where I cut the wires from. So there's one here and one here. So you know, I'm going to put a wire on, extend this one over into this area. Then I'll be able to mount this like so. Maybe like that to connect the black wire, red wire. Okay, I got to run two wire extensions, 2 extension wires. Okay, that'll be what I'm going to do. Okay, so what I've done here is I've basically soldered on extension wires right up close to the capacitor, so I can cut off the bare wires. And now I basically have 2 insulated wires. Why not 3? Because the red wire is going to be the 3rd one. Okay, so this is going to attach to the black right there. And then we're going to want to run this over here. And the blue one down here. Blue one might be a little too long. Yeah, you can just see how the insulation's just crushing off of that wire. wire. Now the next one. Can shorten this up a little bit. Pulling the old insulation off the little bit of wire I left there. Red wire coming over to catch the last positive. Sometimes these wires that come from the main capacitor go to difficult to reach places. And if you preserve the wire, if you can preserve the wire when you're doing the replacement, you don't have to get down into those difficult places in the radio to do it. Last one is the ground connection here. Negative, I guess I should say, really. Now the fact that I'm putting in big fat capacitors, double the size of the ones that were in there, can cause problems. You know, the instant you turn it on, of course there's the inrush current. Don't know that all these three capacitors are subjected to inrush current. But during that moment of inrush current, the voltage across the capacitor is 0. And this places can cause, result in a lot more voltage showing up somewhere where it isn't normally there for very long. Usually across the rectifier, I think. And so if you get too big a voltage at the startup across the rectifier can arc inside. Now, is that a real risk for this radio? I don't know. We'll find out. I think only one of these capacitors was right on the rectifier. I'd have to look again, but I think the other ones were not. This is not going well. There we go. Okay. Super capacitorized. Now what was this? Is this really what it was supposed to be? I've got the band right on top of the values. There we go. 40, 20, 20. So this is probably the original. Often you'll find the replacement ones don't match much better than the one I just put in there. The three I just put in there. Okay, quick check. Make sure nothing is shorted here. Nothing's going to fall off suddenly. Everybody's connected and happy. Looks like a happy situation. Okay, we're going to try the radio again. Just avoid putting my finger through the speaker. Okay, switch is on. Power is not. Just neaten things up a little bit here. This radio is going to make radio. It's going to work like a radio for the first time, and who knows how long. That's probably what's going to happen here. Switch is on, volume is down. Okay, here we go. Through the dim bulbs. How'd they both get in there? They weren't both supposed to be in there. I think we're hitting her with 108 big ones. No hum. Ooh, what's that sound? Oh, that's coming out of the speaker. That sounded like something burning up fast there. We have soundage. Ooh. That'll get my cat's attention. Hey, it's not working. Okay, power off. Now, last radio I did, a little radio I did, full of original parts, and turned it on after just putting a power cord on it, and it worked hum-free, original parts. Shocker. Not so lucky with this one. So it could be the first thing we need to do is check the tubes. I think that's probably the best thing to do, and I think I'm gonna leave that for tomorrow. I think that's it for today. So tomorrow we'll start some real troubleshooting on here. See what we can find. Thanks a lot for watching, and enjoy your day.